if it loads. We all sound so tired. All right, question 1 and 2 we should have.
Yeah.
All right.
Is Kendra?
What's
She's
that?
on mute. I don't know if she's agreeing with us.
What's going on?
I said, Kendra, I don't know if Kendra is there.
I think she's here. Her microphone is on mute, though.
Sorry, I should go back.
There we go. All right. Who wants to do the first one? Question 3.
I'll go. All right, question 3. Let's see. Use this information probability when calculating anything.
Hey, Mike, your mic.
Yeah.
Somebody's mic has got a lot of feedback. Hello?
All right, that's better.
Okay.
All
Yeah,
right. See,
it was very
when calculating
echoey.
anything, please remember to round to 3 decimal places. Do not round until your calculation is complete. In an ANOVA hypothesis test, we reject the null hypothesis when there is a sufficient evidence to indicate at least one mean is different from the others.
I think it's the alternative.
Yeah,
Are we on question 3?
Yeah.
Okay.
Hold on. Let me look at my notes.
Yeah, I think it's when the alternative.
Oh, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. Well, I think, isn't that true?
Yes.
Oh, true.
Yeah.
Oh yeah, because then it would, yeah. Okay, so I'll repeat question 4.
Hey, guys, is this better?
I think it echoes.
Do you guys still have the echo?
Well, it's not you. It's like when other people are talking.
Gotcha. Okay, I just put in headphones.
It's not as bad though.
Okay.
I don't hear myself echoing like I did before.
Yeah, I don't hear it either.
I just put headphones in.
Okay. So question 4 is, what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
The sample mean should be positive, right?
Yeah.
Yeah, that's correct.
And then the data is normally distributed.
Mm-hmm.
But the variance is not number 3, so A and B.
Yep.
Well, I'm looking in the textbook. It says there are 2 requirements of ANOVA that must be checked. The data are normally distributed in each group, and the variances are equal for each group.
Oh, yeah. You know what? That's for the F distribution. It says values of F are never negative.
Mm-hmm.
So I think it just be
negative.
Oh, okay. So
okay, so that makes sense. So we're just saying B then?
And C.
B and C.
B and C.
Wait.
It's just right underneath. So if you're looking in the textbook, it says requirements for ANOVA. The data are normally distributed, and the variances are equal for each group.
Okay, let me go to that really quick. Hold on. Sorry.
Well, I have like all the samples are from simple random sampling. The samples are independent. The population have the same variances.
Yeah, so the same variances.
Oh, yeah. Okay, I see that.
To check if each group is normally distributed, do the following.
So, wait. So on question 4, we just go B and C, right?
Yeah.
Hmm.
Okay, want to make sure.
So for question 5, would it be construct a histogram? Because that can pretty much give you a view of the curve.
I got QQ plot.
Yeah,
Yeah.
that's what I think. It's the QQ plot.
Let me look that up. Okay, that makes sense. Okay, because you can tell that the data sets come from populations with a common distribution. Okay, gotcha.
Yeah.
Okay, who's got 6?
We assume
Go for it.
We assume that the variance in each group is the same in the following happens. The sample variance for each group is smaller than the sample mean. The larger variance is less than 4 times the smallest variance. The larger sample mean is less than 2 times the smaller sample means. Each group has the same sample size.
B, right?
It's B, yeah.
Yeah,
I would agree.
you're less than 4 times the smallest variance.
Mm-hmm.
Okay, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? 4?
No, I have 5. Wait.
I need a piece of paper.
I have 6.
So it would be
I have
1,
1,
2,
2,
1, 3,
1,
1,
3,
4.
1, 4, 2, 3, 2, 4, and then 3, 4.
6.
Yeah, 6. All right, and the next question, we're using the soccer shoes file. And it says, what is the minimum smallest variance for the 6 groups?
We're
So,
soccer test. The soccer
Mhm.
shoes. Okay.
footwear A, just copy the columns, I think, right?
Yeah.
So wait a second, because there's like A, B, C, D, E, and socks. How do we?
We put all
So
those. That was on the preparation one. So we just put all those onto the variables 1, 2, 3, 4.
Okay.
They just didn't lay it out all nicely for us.
No.
We just have to find all that A and then B and then C and then the D, E, and then the socks.
Socks.
Yes.
That's not too bad.
No, because there's not a lot of numbers.
Mm. He's munching.
It's my mouse. I'm not munching. It's too late for munching.
What time do you have to leave tomorrow, Kendra?
Well, I'm still going into work for a half day.
Oh yeah, you had
So
payroll
we'll probably
this week.
hit the airport at like 2.
How did that go? How did your
For
new
what?
payroll thing
Oh,
go?
my last week. Yeah, well, we got people paid, but it
Good.
wasn't necessarily accurate, so
Oh
we've
god.
got a lot of work to do. And a lot of upset employees.
I can imagine. So we used all 6 variable columns, right?
Right.
Yes.
Yes.
All right, and then the question says, what is the minimum smallest variance for the sixth group?
I have 20.
Oh, wait, I'm still.
Wait, what?
Okay.
27.358.
Yeah, that's what I've got.
Wait, I have
Oh, wait.
27.208, variable 3.
Yeah, that one is there. That exists.
Oh, yeah. What is the maximum? 158.
53.158. Does everyone understand how we're doing this?
Kelly. Kelly. It's too much noise. Thank you.
Are we on 10?
Wait. I'm still on 8.
8, okay.
Okay, so I mean,
Got 27.208 and 53.158.
Yeah.
Do you see how we got that, Minerva?
Yeah.
no.
Oh.
So we're looking for the variances of the smallest group.
Right. And the what?
Group
did
with
you
the smallest variance.
Just the smallest number there in the variance numbers.
Oh, 27.208.
Yep.
And then the biggest one is 53.
Yeah.
0.158.
Okay, I'm up to speed.
Okay.
Okay, so 10, the test for equal variances is satisfied for these data. I say true.
True.
Yes.
True gap.
You divide the biggest, largest by the smallest, it's less than 4.
Yeah.
So you take the largest variance and divide it by the smallest. Is that what you said?
Yeah, as long as it's less than, the number is less than 4, you're good.
Then it's satisfied. Okay. Gotcha.
Okay, so question 11 says, construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots.
Does anybody remember the Excel file for this?
I was gonna say, is this something we can just pop in?
Yeah.
Yeah, it's the
Is it the other one?
yeah, it's the other one.
The first one that we worked
The
with?
quantitative descriptive
Inference.
statistics?
Yeah, quantitative descriptive statistics.
Oh yeah, it's the second.
Oh,
Yeah,
hey,
it's
QQ
the
plots.
second one. Yeah.
So do we just combine all the data again?
No, you have to do one individually. Why don't we do this where each of us takes a thing so we don't have to all do them at once?
I'll do A.
Okay.
I've got variable 2.
I'll
Also
take the
3.
third.
Wait, who's doing the third?
Minerva.
Okay, Troy, do you want 4 and I'll do 5?
Yeah, sounds good.
Okay.
How do you sort it?
Just highlight it and then go to data, and then
Would you look
sort
at that?
smallest to largest.
I can do number 6 also.
Mine is approximately normal.
Mine is 2.
So is number 5.
Ah,
Oh my gosh.
So number
Is
6,
your guys' program freaking out when you take out the data
No.
No?
out of the QQ plot data?
Nope.
It keeps giving me like an error message when I delete all the
Oh yeah, mine did that too.
variables on the left side.
Yeah. What were you saying, Summer?
so number 6, it doesn't have a distinct curvature, but it has like, it's not following fully the red line. But I think but it says if it doesn't have a distinct curvature, it's reasonable to conclude data are normally distributed. So
mine is not normally distributed.
Which one
Did
did
you
you
sort
have?
it?
Did you have 3?
Yeah, I sorted it. It starts from 20 and the largest is 40.
Mm-hmm.
And it goes weird, like on a vertical line.
Did you have 3, Minerva? I popped it in there. It looks pretty normal.
Really? Okay, let me find out then what I did. Hold on.
Minerva, can you share your screen?
Yes. Let me look.
Close all your terrible websites first. I'm just kidding.
Oh jeez.
She's like, yes, I can.
That one. Uh, can you see it?
Yeah.
Yes, I see me.
Did you see you? Hold on. Move you to a different position, and then let's see.
Oh,
Oh, where'd it go?
I was admiring it. Come back.
I think my computer's freaking out with all these Excel programs open.
Can you see it now? No?
Yeah.
Yeah, I see it. What in the world?
Right? That's why I said I don't know what did I do. I have to.
What is that? What's that last number? It's like a really big number.
589.
Delete that number. The last one in your row. Yeah, delete that.
How did you get that?
That's what I don't
that
know.
didn't change anything.
There we
So
go.
I go there. Yeah, it didn't change anything.
Oh, there you
so.
go. No, it
It's
changed.
normal now.
Okay, thank you.
My pleasure.
Yeah,
All right, so we're going with true.
mine's normal too.
Okay.
yeah.
Do it.
Okay, now remove the SOX data from the original test. Sigh. So SOX is variable 6, right?
Correct.
Yeah.
You're saying we're removing? Oh, then remove. Okay.
Yeah.
And the p-value goes to 0.309.
So we're
Yeah, I got 0.309.
Whenever, did you go back to the quantitative inference procedures spreadsheet?
yes, and I have to remove the sock, right?
Right.
Yeah, remove variable 6.
And I got 1.216.
For the p-value?
That's the F. The p-value is right next to it.
Oh, 0.309.
Yeah.
Yeah.
Ready for 13?
Yes.
Mm-hmm.
The test statistic for the ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the f? It's to the right.
To the right.
Yep.
Well,
Choose the
literally
right.
to the right. Okay, cool.
No.
Aww.
Yay, hot dogs.
Yay.
Anybody
Okay.
hungry?
No.
Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file. Use this data file to answer the remaining questions. Let me download that.
Gross.
We're doing the calories first.
I like how it goes from beef to meat. What's the difference?
Wait, what is it? It's the,
Yeah, let's examine calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
I'll do the beef calories
I'll go ahead and do the meat.
because beef is not meat.
I don't get that.
I don't either.
Meat is just what, random?
Okay. I can do
Yeah,
both.
meat is just every animal.
Just pig. The leftover of the pig.
Just everything.
So I'm doing the
Okay.
poultry.
I've got poultry.
Oh, so which one do we need to do then?
Whichever you want.
Nothing new?
pick one.
I like how we all claimed our own. Mine.
Well, I mean, it's true. You could do any of them.
Okay.
I'm a vegetarian. I'm not doing any.
Have you seen how hot dogs are made?
Let's not. I don't want to talk about that. Mine's approximately normal.
Mine is too.
So,
Kind of.
Yeah, mine is kind of.
Well, now you guys are making me nervous.
Well, I mean, it's like it follows the line, but they're just a little bit
Yeah,
not as close.
So
I
approximately.
think mine's normal too.
Oh, approximately.
Yeah,
Like,
I think
the meat is
they
normal.
look normal.
yeah, beef
Okay.
looked normal. Okay, so
The assumptions have been met.
So we need to make sure that it's normally distributed and that the variances are equal.
Yes, it is safe to assume each group comes from a normally distributed population.
How do we
And-
tell? Sorry, can someone remind me how we tell if the variances are equal for each group?
We can put them in that one spreadsheet.
We
Yeah,
could.
you have to put them in the spreadsheet and divide the
The highest and the lowest.
largest by the smallest.
Right, okay.
So we're doing calories, right?
Yes.
Mm-hmm.
hungry.
Ah,
Right?
it's a lot of work.
Yeah, but it also says that we can assume. It doesn't say we have to figure it out.
Let's assume.
Well, let's see.
That's the only one that can be right because
Yeah, that's because if you look at the other ones, they all say the assumptions have not been met.
Well, it
Yeah.
says construct the QQ plots and compare the variances.
Okay.
Oh, maybe it's the second one. We can't assume that the variances are equal from the QQ plot.
No, we have to actually do it. That sounds like a lot of work.
I think it's B.
Yeah, I think it's B too. I did pop it in. And I don't think they're
They're not
Um, equal. Yeah.
because beef and meat pretty different.
You can't assume that the variances are equal just from the QQ plot.
You
Right.
just assume my variance.
Well, it says and
Are you
compare.
assuming the
Let me
variance?
see.
Are you assuming my variance?
Okay, I'm gonna read 15. Run an
Do I have
ANOVA
to
test to
assume?
determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. that F equals 16.074 and that P is 0 with the level of significance equal to 0.05. What conclusion can you draw?
We're still doing calories, right?
Yes.
Yeah.
Yes.
Don't forget to clear the last 3 columns. That messed me up.
Oh, that would completely screw up your results.
Yep.
I want socks in your meat.
Yep.
Well, we already cleared the socks. We just need to.
You don't want soccer shoes in there at all.
I don't have a 0.00 for P, but I have
No,
a 3 point
Mine's like 3.862.
E to the 6th.
Yeah.
What? What about degrees of freedom? Yeah, they're 2 and 51.
Yeah, everything else matched except the P level.
Why is that?
Except for if you look, it's to the -6, so it would be because you'd.
Zero.
It will be 0.
It's really
Yeah,
close to 0.
Yeah.
Okay, and it says, what conclusion can you draw?
I say
I mean-
D.
The means are not the same, so it's not A.
Right.
Yeah, D makes a lot of sense.
One type of hot dog has types. Yeah, hot dog types has a different mean number. Yeah, I'm good with D.
All right, now we're doing the same thing with sodium.
Boo.
And I'll do the beef sodium.
I'll take poultry.
You're a trooper.
Okay.
Guess I'll do the meat.
So we're doing
Don't
the
forget
same.
to sort it.
Yeah, we're doing the same thing.
All right, with the other one.
Goodness.
Mine is normally distributed.
Mine is, yeah, I guess.
You're instilling a lot of confidence.
Well, the question says that there's going to be a problem.
It does.
You should see the QQ plot for poultry suggests a possible problem with the normality assumption. Who's
What
got
the-
poultry?
I did. It looked normal.
Did you sort it from smallest to low or smallest to highest?
Yeah, let me try again.
Yeah, meat is normal.
Beef is normal.
I did meat too, and it's normal.
I mean, okay, there's a gap.
Wait, can you share your screen?
Yeah. Let's
I want to
see.
see how abnormal yours is.
I mean, there's a little gap, but I don't think it's that big of a deal. This is it.
Yeah,
I mean,
I think that's normal.
that's kind of what I was thinking.
Look at
but
mine
did
and
it-
tell me what you guys think.
Did it imply that it wasn't?
It kind of. What is going on? Okay.
See, that's mine for beef, sodium. You guys see it?
Yeah.
And that looks pretty normal too, right?
Yeah.
Yeah.
Okay, so the question says, you should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75, and the largest is a big number. Have the assumptions been met to use ANOVA?
Well, the variances are good.
But we can't assume that each group comes from a normally distributed population if there's a problem with one of them.
Wait, how do you know that the variances are good?
Because it says the smallest variance is 7180.75 and the largest is 10.
Oh,
And so it's not 4 times is small.
Yeah.
But then I'm kind of nervous because it talks about the poultry problem.
Just says it suggests a possible problem with the normality assumption. So is that to indicate that we should not assume that it's normal? I mean, the only thing that wasn't normal was that there was a gap. But it generally follows the line, which is annoying.
Yeah.
So I guess it's saying that we should assume it's not normal.
Mm-hmm.
So that would be C.
Gonna do B?
C, I think, because
C.
they're not all
Not
normal,
safe to assume each group comes from. Yeah, I think C.
but the variances are good.
Yeah.
Despite the possible problem that we don't notice with the QQ plot for poultry, you decided to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? All right.
0.179.
Yeah.
Oh, wow.
Is everyone good with that?
Yes.
Okay, what conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a significance level of 0.05. I want to go with B. We do not have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels.
Yes.
Mm-hmm.
I agree.
So we are failing to reject.
Who would like to submit? I'll submit.
Okay.
$95.
Which one did you get wrong?
We missed number 14.
Okay, I think it's A. I'm going to submit with A because I think it was B. Is that right that you submitted with B?
Mm-hmm.
Okay, I'm going to submit with A.
I accidentally closed my window.
Oh my gosh.
Did someone submit?
Yeah, I submitted.
How did we do?
We got a 95, and she's about to submit with a different answer for number 14.
100. So 100
Okay, so it was A.
A, yeah.
For 14?
Yeah.
Was that the normally distributed one?
Number 14 is, it was asking about if the variances to determine if the assumptions for the hot
Oh,
dog.
we could assume that they were equal? Huh.
Yeah.
Interesting.
Could someone read me the answers?
Yes. Okay, 1 is B, 2 is B. All right. 3 is true.
Okay.
Question 4, B and C.
Mm-hmm.
Question 5 is C. 6 is B. 7 is 6. 8 is 27.208. 9 is 53.158. 10 is true. 11 is true. 12 is 0.309. 13 is right. 14 is A. 15 is D. 16 is C. 17, 1.79.
No, 0.179.
Thank you.
Thank
0.179.
you.
Oh, I didn't save my 18. Where did it go? We do not. So B.
Yeah.
Alrighty. Thank you. Sweet. So should I stop this or just submit one video file like we did usually?
Oh yeah, because we have to submit by 10.
Do we? No, it's not due till tomorrow.
Oh yeah, that's amazing. It's Monday.
Yeah,
We can
so
keep going then.
We can keep going.
Yeah, we can use the same one.
All right, lesson 15.
Okay.
Let me close all these Excel windows and just start again.
Right?
It's intimidating how much I have open.
This is the review for the exam.
Ew.
This is probably gonna be a 30-question quiz.
I think it said that it's going to be the same ones as the review.
Oh, really? That makes sense. I
Yeah.
think it was like that last time.
Okay. What are we doing?
And
Wow.
it's 32 questions. I was wrong.
Oh my gosh.
Okay.
Ew.
So it's not the same one.
Look at all the files.
I know.
Oh my gosh.
Are we ready? He's gonna watch this video and hear us complaining and be like, "Wow."
All right, let's just jump in. Question 2. Given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence level? Oh.
A.
No. I don't
Oh,
think
no. No, sorry.
I want to say
B. Yeah,
Yeah.
B. Okay, you know what? Here's the thing: is I'm looking at the review, like,
Mhm.
and the answer is A on the review, but they've moved them around. Like they.
Oh,
moved the
yeah,
answer.
I see what you're saying.
So I was like, oh, it's A, and then I
Oh.
actually looked at A, and so I gotta be careful on that.
They're trying to trick you.
Yeah.
Yeah.
So we're going B,
Yeah.
Yeah.
which is A.
Yes. Yeah.
What?
I'm messing with you. It's B.
It's too
Oh,
late.
Wait. So the 2 is, I have it as B.
Yeah.
Uh-huh.
Yeah.
But it's also D.
Stop.
Well, depends on what test.
I'm reading the next question. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the student to respond to a particular stimulus and not to respond to the other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples to see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Ugh.
Well, that's obvious.
Is it?
I said
No.
C, but I have no clue.
I'm gonna go back
Wait.
and
I gotta reread that.
yeah.
It's too much input and at one time.
And Kendra sounded really happy when she was reading the question.
I'm so happy. I'm going to Disney World tomorrow. Why couldn't I be
That's
happy?
exciting.
Yeah.
Just don't buy any food there. Eat before you go.
Oh my gosh, we are buying all the food. We
So
did Disney World
expensive.
on the cheap growing up, and we're like, we're eating in the parks.
Nice.
Get the fast pass.
Oh yeah,
Going all out.
oh yeah. My brother got it, so we're staying on property.
And the weather here has been in the 50s, so it's going to be awesome.
Yes. Okay, focus. We have 30 questions.
Focus.
No, we have 29 now.
Okay.
No.
I'm rereading my notes. It requires the instructing and confidence interval satisfied. Requirement. Okay, there are 3 requirements that need to be checked when computing a confidence interval for a mean with a known standard deviation. Well, that's not helpful. Okay. 2 requirements that need to be checked when computing a confidence interval for a mean with an unknown standard deviation. Simple random sample was drawn from the population, and the sample mean is normally distributed. So we just determined that the confidence interval would be so random samples, and they are approximately normal.
Check, check, and check.
So is it C?
See?
Yes.
That's what I'm guessing.
Yeah,
That's-
I can
yeah.
see.
Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Oh. B?
Yeah, because we don't know the standard deviation, right?
Yeah.
What do you guys think?
I have no clue.
I have the confidence interval for the difference of means using independent samples.
Yeah.
That's what I had, but I don't know if that's right. I was kind of going with you guys.
Well, they are independent samples.
Let's see.
Let's just stick with B, and
I don't know.
if it's wrong, we'll redo it.
Perfect.
So we're going with B?
Mm-hmm.
Okay, so number 5, I'll read.
Go ahead.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be those 2 numbers. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
I'm thinking either B or D.
So I said C.
None of them?
Because when the higher you go, let me go back to my notes. So if the confidence level is increased, then the margin of error would increase. So I don't know though.
I'm thinking maybe B.
I think it's B, because then you know the higher the confidence, then your margin of error is less.
Yeah, you know what it is. I think it's D.
You say D or B?
Wait, what?
I say D as in dog.
Using dog?
Yes, because in my notes it says if the sample size is increased, the width of a confidence interval will decrease. And isn't that so? That would
But
give a
30,
smaller margin of error.
but 30 is a large number. If you have, you know, the sample of 30 customers is considered a large number, though.
Okay, so what is everybody going with?
Well, I can see what you're saying, though, because if you have a larger sample size, that is the denominator of what you're using to calculate the margin of error. So if you have a larger denominator, wouldn't that make, oh, I'm losing my train of thought. That would make the, wouldn't it make it smaller?
That's what I say.
I wish this was like, plug these numbers in and tell us what the confidence interval.
On those, yeah, those right here where I have to give a straight answer, I'm not good at it. So are we going with D? 90 bank customers rather than 30?
Gives you a bigger sample, more accurate.
Yeah,
I'm going
let's do
with
that.
yeah. Let's do that.
What are we going with?
Using dog.
Okay.
It's a bigger sample.
All right, I'll go ahead and read 6. Factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shaft. She randomly selects 4 drive shafts made at the factory, measures the lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound and upper bound.
How do we even start?
Well, you can use the margin of error.
We pray.
Calculations. If I look at my notes, margin of error is M is so if you're doing a 95% confidence, it's 1.96.
Right. So the sample mean would be 1,000.
Standard deviation divided by the square root of the sample size.
Were we given standard deviation?
2.
Yeah. It's 2.
Oh, there. Yeah.
Kelly, can I borrow my phone so I can?
What's the sample size?
1,000. Or no,
That's
not
the
the
mean.
sample size. 4. She randomly selects 4 drive shafts.
Oh, yeah. Okay.
So it's 1.96.
Push the button so I can turn off what I was listening to.
Which is 2 divided by 2, which is 1 times 1.96.
1.96. Yeah. Yes.
You guys concur?
Mm-hmm.
Yes.
What's the lower? Hmm.
1 point.
So we'll do 1,000 minus 1.96, 998.04, and then 1,000 plus 1.96, 1,000, 1.96.
Yes.
Okay. Is everyone good with that?
Yes.
Okay. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean and standard deviation of 0.01. How large should the sample size be so that 95% confidence interval for U has a margin of error of plus or minus 0.0001. Okay, cool. Find the sample size.
So I got 38416.
Oh my word, I haven't even written down my formula.
That's what I got. Well, I did it before we met together, you know, the test.
Oh, right.
Oh, you guys
And
prepared.
that's what I got, 38416.
Maybe it's fine time for that.
Hey guys, my quiz closed out and I didn't hit save for 6 and 7. Does anyone have that?
I think you're out of luck.
Yeah, we're done.
Mine
Get out.
deleted.
I'll just go cry.
6.
6 is 1.96. And 7 is 998.04.
3.
That's a big interval.
Minus?
Thank you.
For 7 is minus.
What? Why
For
is it
7
minus?
is yeah, minus 998.04.
No, it's still positive.
Yeah, how'd you get minus?
You just take 1,000 and you subtract the margin of error.
Because you're taking the lowest bound, the lowest, what is it called? The lowest bound, the lower bound, and that is minus.
Well, you
Not always.
subtract the margin of error from your sample
From the mean.
from the mean. Thank you.
So
Okay.
then the upper bound is 38416.
What?
No, the upper bound is 1,001.96.
Right.
Okay.
You just add the 1.96 to the mean, which is 1,000.
Look at that.
You're right. When I put my answer on the mean on my paper, what I did, I put the lower, which is the minors. I guess that's where I got confused. Sorry. You're fine. It's positive.
Okay, so I got for 9, and I feel like this might be totally wrong, but 38,416.
That's
Yep.
correct.
Okay.
Do you guys know how to get to that one?
That caught you flirting again.
Yeah, so then are we at number 10 now?
Yeah.
10,000.
Wait, how'd you guys get 9?
So you take the 1.96 times 0.001 and then divide that by 0.0001, get the answer, and then square it.
So you're basically using that formula from before, but you're rearranging it to solve for.
And so it's the formula
sample size?
is, yeah, so the formula is the z times the standard deviation divided by m.
Oh, okay. I got it.
Yeah.
I got you. I'm picking up what you're throwing down.
Okay, is everybody at 10?
Yeah, go ahead. Or what was the answer for 10?
We haven't read it yet.
We haven't read it.
Okay.
How about you
It
tell
was-
us, Troy?
Sorry, what was the answer for 9?
9 is 38416.
0.38416?
No, 38416.
Who's Johnny?
That's me.
That was me.
Oh,
I'm just kidding.
All right.
Sorry.
I'm ready for 10. Sorry.
You want to read it, Troy?
Yeah, the mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis H and H are for you are I can't keep track of all these stupid symbols. What is that, the mean?
Yeah.
For the mean,
I said
I'm gonna go with
D, right? It's B?
D.
I got D as in dog.
D,
I
yeah.
also have D.
Me too.
All right.
Who was saying B?
No, D. The last one.
the last one.
It was you, Mike.
D is in duh.
Yeah.
In a
Something like that.
statistical test of hypotheses, we say we reject the null hypothesis with the level of significance, what is that, alpha, if
Yeah.
blank.
Yeah.
The p-value is less than alpha, isn't that what it is?
Yeah. So B.
Yeah.
Mhm. Guys, it's
Oh, I see.
almost midnight.
Ugh. You have early work tomorrow?
Mm-hmm.
Ew. Okay. We're almost halfway, but not quite.
I have to get
I go to work in
7.
3 hours.
What?
Yeah, I work nights.
Oh,
Oh,
gosh.
that's horrible.
Let's
All right,
not
let's
think about
move
it.
on. Okay, a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample size of 15, okay, from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use ANOVA hypothesis test to answer their question?
That I didn't know how to answer, so I put that no, they don't have enough data.
I
They
said,
don't have enough.
The sample is too small.
They don't have
Yeah,
enough groups. So they have more than one group.
And the NOVA is not bell shaped, it's just right skewed.
Right? 4 different apartment buildings.
Well, wait a second. They are bell-shaped, and the sample variances are equal, right? This is not the qualifications.
Yeah.
Well, bell-shaped doesn't necessarily mean normally distributed, does it?
That's what I was wondering. Doesn't it imply normally distributed?
yeah.
Yeah.
Well, that's not true, because it could be bell-shaped on the left side
Mm-hmm.
and be right skewed.
So I said I didn't understand that one, so
But it also says there's no outliers. So if there's no outliers, does that imply that there's no skewing?
I think.
Yeah, I think
You
it's
were
C.
onto something when you were saying it could be bell-shaped and right skewed, which isn't normal.
Right. But
And so I'm thinking it's A or A.
well, the standard deviations are
we don't know them.
I
Or
don't think
B.
you have to know the standard deviations.
I say it's yes.
Why? Defend your answer. Like C?
C, yes.
Or B. Because both of them say yes.
It is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
I have no defense, but that's what I
The defense rests.
Yeah.
Okay. I want to rest.
Want me to read the requirements for ANOVA?
Well, it's the data are normally distributed in each group, and the variances are equal for each group. So it goes back to my question: is does bell shape imply normally distributed?
It's supposed
I
to.
think bell shape with no outliers implies normally distributed. 'Cause if there were outliers, then it would probably skew it. I'm fine with C.
Okay. I will take responsibility if it's wrong.
You're fine.
I mean, I'm okay with the C if you guys are okay. As I said, I didn't know it, so.
Are you guys ready for 13?
Let's do it.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significant level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer.
Okay.
What
So
type of error?
she rejected it. She rejected the null hypothesis when the null hypothesis was true.
Which is a type 1 error.
It's type 1?
Yeah.
Are you certain?
Defend yourself.
What chapter was this? Does anyone remember?
I'm looking. I think it was chapter 6.
Number 9?
Hold on.
A type 1 error is the incorrect rejection of a true null hypothesis.
I'll take it. Does it, in your notes, Summer, does it say what chapter that is?
That's what I'm looking for.
It's chapter 9. I mean,
9?
it's like, it's lesson 9.
Okay.
The type 1 and type 2 error.
Yeah.
There you go. Yeah.
Yeah.
So null is true and is rejected. Type 1 error.
Yes.
Okay. So A.
Yes. Okay, so then number 14. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
I put A.
That's what I have.
Yes. I'm just reading that in the textbook. The probability, so if the A value is very small, the probability of committing a type 2 error will be large.
Okay, perfect.
I was like word for word.
Yeah. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams U and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypotheses. At 0.05 level of significance, you conclude that you should, okay. So we're trying to find the p-value to figure out if we want to reject this.
Yeah.
Yes. How do we do that?
Do we go back to the applet?
We find out
long ago?
the Z score.
The z-score. Oh gosh, how do we find the z-score? Does anyone remember?
Yeah.
Not off the top of my head.
No.
I got notes here. Hold on. Z score.
Our teacher's gonna watch this and just
He'll be
palm
like,
face.
really?
Yeah. You're like, I'm sorry I didn't log this away.
It's
the mean minus the mu.
so the z-score is
Standard deviation of the square root of
that-
number.
value minus the mean, so divided by the standard deviation. So it would be
Is it U minus X or X minus U?
X minus U.
Okay.
Yeah.
So 1.53 minus
1.5.
minus 100, right?
No, that's the sample size.
That's the sample. That's the number.
It's 1.5. Yeah, Minerva's right.
1.5.
Divided by 0.17.
No. Well,
Isn't it divided by the standard deviation?
yeah.
Okay.
Sorry, I have something different, so I'm trying to figure this out.
Well, I could be totally wrong. I'm willing to admit that.
No, it's a well, I don't know.
Oh gosh. Well, they wouldn't give us a sample size for nothing. Are we trying to find the t value?
Okay, so
Yes.
I think it's the value minus the mean divided by the standard deviation, which
Right.
I actually have equals the standard deviation divided by the square root of n.
Okay, that gives us something different.
Yeah, that's
Well,
what.
I don't remember what that gives us, but it gives us something different. Is that what gives it? What is that formula for?
I don't know. It's probability calculations involving a mean response.
Yeah, you lost me.
Yeah.
Sample means. Okay. Oh, standard deviation of sample means. Okay. So we're going to do 1.53 minus 1.5 divided by, oh, where did it go?
0.17.
0.17.
Well, the square root, or yeah, 0.17 divided by the square root of 100.
Yeah, which is 10, right?
Yeah.
So I came up with 0.558.
1 second. You got what?
0.558. I don't know what I did.
I got 1.764.
That's what I
Got-
got. 1.67.
Mm-hmm.
Okay,
I
wait.
guess-
1.6.
Got 1.765.
So is that what we put into the
Applet.
applet? And then the p-score is the area on the right side?
You want the greater than?
Well, I don't think, oh geez.
Yeah, test the
Okay.
area greater than if the p-value is
Right, well,
less
yeah.
than the,
Well, so doing greater than, we would highlight the right side, right?
yeah, you want to highlight the right side to see if it's greater than.
Then I'm getting an area of 0.038,
That's what I got.
which is less than the level of significance, right?
So we reject it.
Yeah, where was the level of significance?
We're rejecting the null,
I
right?
think the answer is-
Oh, there we
0.05.
go. 0.03, 0.05. So, yeah, we reject the null. Fail to reject. So D?
Mm-hmm.
My gosh, that took forever. Summer, are you in agreement?
Yes.
Okay.
That was one question.
I'm not going to remember this on the test.
Yeah.
And I have to do this.
It's hard to go back that far and remember, those type of formulas all the way back.
Okay, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Oof.
Would that be independent samples?
That's what my guess was.
That's what I got, independent sample test.
Yeah.
Yeah, I agree with that.
That's the
Right.
one where you do the subtraction, right?
Mm-hmm.
Yeah.
Or is it paired? Paired is where you have the differences.
Paired is where one is, isn't it? One is dependent on the other.
Yeah, one outcome is, yeah, you're right. All right, 17. Anyone want to read it?
An educator is
I got it.
interested in okay.
Go ahead, no, go ahead.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent? That would be dependent.
Dependent.
Yeah,
I said D.
Yeah.
Yeah.
It's not B.
No.
No, it's the last one.
That's
No.
really sexist.
Well, even though it's true. Funny.
Got him.
I'm the youngest of 4 brothers, and I was the high achiever, so.
I just have a bunch of dogs.
Okay. Who's going next?
A soil scientist collected random soil samples from a field and measured the dissolvent organic carbon on milligrams level of each sample. The measurements are recorded in dissolved organic carbon. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of the confidence interval listed below, which one is appropriate for the situation?
Well,
I have confidence interval for the mu when standard deviation is unknown. 8.
I don't know it.
That's what I got too, but I don't remember why.
Because it just has a bunch of numbers. We don't know the standard deviation.
Well, but if we put it in the formula, wouldn't we get the standard deviation if we put it in the spreadsheet?
Yeah. What?
But yeah, but that's one of the first ones that we, the formulas that we learned. I mean, the number 10, that's less than number 10, I believe.
So, I mean, like, if we put the data in the one sample t-test for means, it gives us the standard deviation.
I don't like that. I wish it didn't.
Yeah.
Yeah, it spits out 4.326.
Yeah.
Yeah. Conference now.
Well, it's not B or D.
So, see?
Yeah.
Okay.
Which of the following is a 95% confidence interval for this analysis? What is the margin of error?
Okay. So 15.217 minus 11.168 divided by 2. 2.025.
Divided by 2 point what?
So you take the higher bound and you subtract the lower bound
Right.
and then divide it by 2.
2.0245.
Oh yeah, this is the one that I had trouble on last time.
And so the lower bound is 11.168,
That's what I got.
Yeah.
and the upper bound is 15.217.
Yes.
Moving right along.
Wait.
Yeah.
I got 2 different numbers.
I was waiting for that.
I got 2.025. Is that what?
Yeah,
Yeah.
that's what I got.
That's, well, that's correct for the margin of error.
For number 19, right?
Yep.
Mhm.
Okay. Am I way behind?
Oh,
No.
you're fine.
Okay.
The lower and upper are just right there.
I'm on that one. That's why I said, wait.
Okay.
Oh, you know what? I wonder. I'm like, my numbers are far off. There we go. I had a 99% confident interval entered
Gotcha.
for some reason. Okay. What'd you guys get?
For the lower or the upper?
4.049 for the margin of error.
2.025.
Yours is like double.
Oh crap.
Yeah, so I think you just have to divide yours by 2.
Oh, divided by 2. That makes sense.
Mhm.
Yeah.
So I keep you guys around.
Aw. Wow, the Hummer spreadsheet gives me a headache.
I know, I was just looking at that. So we're not going to use the paired sample test because the one outcome isn't dependent on the other, right? So we use the 2 sample t-test?
Mm-hmm.
Okay.
So are we on 22?
Yes.
Okay. I said C.
Of the 4 types of confidence intervals listed below, which one is appropriate for the situation? Just ask me what the numbers are. Confidence interval using independent samples.
I think that's right because they're all from different dealers.
That's
Yeah.
what I have.
I think so too. I would agree with that.
Did it taste bad? Did it taste bad? Answer the question. Did it taste bad? I'm not gonna get this right until you answer the question. Did it taste bad? Yeah.
Wait, what are we answering for 22?
Did it taste bad?
See?
See?
Yes.
Si, senor.
Did it taste bad?
Yeah.
Yeah.
Yes.
Okay, calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and New York. Why is that a question mark? Okay, input
I
your
was
answer.
wondering the same thing.
Input your answers for the lower bound and upper bound. Okay, let me get my stuff up.
So we're copying all of LA prices first, right?
Yeah.
What type
And are
of
we
test are we
using-
doing?
Is it the 2 sample t-test?
Mm-hmm.
Yeah, it's the T-sample to test.
Where's, oh, there's New York. Oh, there we go. I got it.
Way down there.
Price.
Who buys a Hummer?
Weird. Okay, so what's the...
All people that are preparing for the zombie apocalypse.
Right. So the lower bound is at negative 423.238.
That's what I got.
Yep.
And the upper bound 5417.336.
Yep.
Yeesh. I guess we are talking about car prices, so okay.
Yeah. I don't like how there's a negative one though.
Yeah. That's seriously all we had to do for that one? Okay.
What are your decimals?
0.238 and 0.336.
On the lower?
Lower is 0.238.
We'll read the full number.
Negative 423.238.
And the upper is 5417.
0.336.
Okay.
25. Did you guys get ANOVA?
I'm still reading it. One sec.
Yep.
I did, yes.
Okay, well, I guess I won't finish reading.
Well, let's read it.
So many Excel sheets.
Don't forget to delete all the other ones.
Oh
Yeah.
my gosh. Worst part is copy and pasting.
Yeah.
You know, just be fortunate that you have something to copy and paste. What does that even mean?
Example. Let's see.
So the
Okay,
test
the
statistic.
And that's the F, right? F value or whatever.
7.978.
That's what I got. The P value 0.002.
Mm-hmm.
Okay, so we're going to reject the null. So it's going to be A or D or E.
There's E.
Yeah.
I said C. 1, 2. Is that no D? 1, 2, 3, 4. D.
So at least one of the groups is different from the mean bone density of at least one of the other groups. Okay. And that was the whole point of the test, right? I forgot what we were studying.
I know.
So we were trying to see if bone density increases, right? And it's saying that, oh gosh, what was the null? Does or does not?
Would like to determine if the mean levels of bone density are different between the three groups.
Well, so the null hypothesis is saying that there is no difference in the mean levels of bone density.
Okay, so the null hypothesis is all the means are equal, and then the alternative is one or more of the means differs from the others.
Okay. All right, yeah, so I'm good with
What?
D as in dog. Any naysayers?
Any opposed by the same sign?
Oh, for shame.
Oppose. Noted.
Okay,
Talk to your stake president.
Can't argue.
Oh gosh.
Pressures, I'm going to go on. So pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. The data are recorded in the direct flight costs. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use the level of significance of 0.1, and then for the next 4 questions, do 40 days minus 90 days for the analysis.
Oh, so
14 days.
Yeah.
What is the correct hypothesis test for this situation?
Paired sample, is that an option?
I think it's a 2 sample, like the independent samples, isn't it?
Yeah, I think it's independent.
Isn't it? It's not dependent?
I think it's dependent sample.
Because you're
Are they
checking
dependent on each other?
you're checking the price of the same flight just 90 days later. So like
Okay.
the sample's the same, it's just 90 days later.
Oh yeah, because it'd be dependent or like, yeah, matched pairs because it's the same thing.
That's what I think.
Yeah, I changed my
It's not they're not looking up the same flight. They're looking up a different flight to the same destination.
No, it is the same flight. It's just purchased 90 days in advance versus 14 days in advance.
So are we using the paired sample t-test?
That's what I'm going with.
I think so. Now yeah.
And then variable 2, is that going to be the first price?
It's going to be the 14-day.
Yeah.
Okay, that's what I did. And so the test statistic, that's going to be negative 1.685.
I
got
have
positive.
I've
That's
got
T, right?
I've got 0.142.
Wait,
Wait.
did I set it to not equal to or?
Oh. I don't know.
You've got what? What did you say?
Well, the type of test doesn't affect the yeah,
Mm-mm.
value.
I have one.
So I've got 0.142.
I have 1.685.
That's what I got too.
Negative.
1.85.
I have negative 1.685.
Did you put your numbers backward?
So I did 90 days in variable 1 and 14 days in variable 2.
I switch them around.
Oh,
Right.
actually, I didn't get all the numbers. It didn't go all the way down.
Yeah, so 1.685.
Let me get all the numbers. It didn't copy all the way down.
0.097, 0.096.
But you're saying, well, wouldn't we do 14 days in variable 2 because that's the point that we're taking the second.
That's
because
the after. Yeah.
we do 90 days first.
And that's what I had done, and it gave me just the same thing, only negative.
I cannot get this full amount of data. So I've got negative 1.685.
That's what I had originally.
And,
Okay.
and to what?
So
Now it's just 1.685.
So on the review, it gave you multiple choice, and negative 1.685 was not a option.
Well,
Is 1.685 an option?
Well, yeah, 1.685 was an option.
That's an option, yes.
Sounds like a winner.
this is really going to trip me up on the test.
So the p-value is 0.096.
Well, so that one we really do need to determine the type of test. So perform the hypothesis. Oh my gosh. Okay. Perform a test to determine if there's a difference. So it's just going to be not equal to. Right?
And so 0.0, yeah, stays the same.
Wait, what?
0.096.
Okay, good. Yeah, that's what I've got.
Oh, yeah.
Thank you.
Last question.
Which of the following best expresses the conclusion of this test? Use a level significance of 0.1. So we reject the null hypothesis, right?
Mhm.
Yeah.
Meaning there is sufficient evidence to conclude that there is a difference in the mean cost. So B.
Mhm.
Yay. Okay.
Who wants to submit?
I can. Here we go.
65.
No,
I'm just kidding.
93. Okay, so we missed question 18.
Okay.
And
Oh, okay. I still think that one was A.
question
That's-
4. That's hilarious. They're both like the same question.
We're really bad at those kinds of questions. So for 18, remember our logic was, well, wait a second, we put it in the applet, or not the applet, but the spreadsheet, and it gives us the
Yeah,
standard deviation.
that was my logic in any case.
Okay, so I think it's A, the 14, and then the 4.
4.
Let's go with D.
Yeah, try that and then submit it. See what it says.
What? I'm gonna try C because I had C on my my review. I don't know why. But
And let us know.
Okay, so I changed it to A and then to C.
What did you guys get for 31? I don't know why my p-value came out really weird when I put all my numbers in.
31, I got 0.096.
Okay, I got 100.
Yay. Okay, can you read?
Submitting.
Yeah, let me go up and okay. So where are we at?
2?
Okay, so number 2 is B.
Okay.
Number 3 is C.
Okay.
Number 4 is C.
Woohoo. Good job on that.
Number 5 is D. Number 6 is 1.96. Number 7 is 998.040 or 04.
Okay.
8 is 1001.96.
No, I don't.
Number 9 is 38416. 10 is D. 11 is B. 12 is C.
Yeah.
13 is A. 14 is A.
Woo!
15 is B.
D as in dog?
Yes.
Okay.
16 is B, boy. 17 is D. Oh, okay.
I'm going to take us off air. Hang on.
Okay.
I just want to get that link for you guys.